All right, so here we're doing 30 special triangles. They're right triangles, and then they're special because they have special angles. One of them on the left side is this one, which is 30, 60, 90 triangle, and the other one on the right side, which is 45, 45, and of course it's going to be 90, 45, 45, 90, but it's called more 45, 45 triangle. So let's start with the easy one, which is the right side triangle. First of all, it's called 45, 45. So it's given that these two angles are 45 degrees. And then we know when two angles are 45 degrees, and this is 90 degrees, and it's independent of what it is. Two angles are 45 degrees, two angles are same. We can say that this is also an isosceles triangle. See, you're familiar with this kind of triangle. It's drawn like that, isosceles triangle. Means the segment is equal to segment, two sides are equal. And also two angles, corresponding angles, means opposite to the segment, which is this angle, and opposite to the segment, which is that angle. So these two angles are also congruent. Now we have opposite of that. We know angles are same. These two angles are same. Therefore, opposite of these angles means the segment is same as this segment. All right. So that's why like that. So if this is x, one of them is x. Therefore, the other one is also x. These are called legs of right triangle. So a right triangle has three sides, right? Like any other triangle, they have three sides, right? But two of them are called legs. The one that they're connected to 90-degree angle. These are the legs. This side and this side. These are the legs. And since these two angles, I just said if these two angles are same, therefore these two sides are same. They're both x. And this side, this one, which is opposite to the 90-degree, that's called hypotenuse. Now there's a relation, 45, 45, 90, between these segments that you can memorize. First of all, I already said one of them, which was easier one. If this is x, that's x. Means if this is 2, that's 2. If this is 4 centimeter, oh, that's 2. This is 4 centimeter. They're same, so x, right? Mm-hmm. The next one that you need to know is what? The hypotenuse. If you have one of these legs, no, we don't need to use Pythagorean theorem. If this is 2, that's 2 rad 2. You multiply by rad 2. You can use Pythagorean theorem to find it, but that's the whole purpose. This is kind of formula, faster way of finding the hypotenuse without using Pythagorean theorem. So if this is 2, you just multiply hypotenuse, but that 2 by rad 2, you get hypotenuse, which is 2 rad 2. If this is 4, like this case, then that's going to be what?
4 rad 2.
4 rad 2.
Now, some of them have rad 3 and...
Yeah, we'll talk about that. So now if this one of them is, if this is now this segment is 10, means this is also 10, and that's 10 rad 2. All right, so basically it's like this. So x 90. So 45, 40, let me do this. Some teachers come up with this formula. I've seen it, so I'm going to explain it that way too if you have such thing going on at school. So 45, 45, 90. These are the angles. And then segments or side, that's x. The other one is x. The one which is 90, which is opposite to 90 hypotenuse, corresponding side is this one. That's x rad 2. So if x, I already said it. If x is 2, the one of the legs is 2, the other one leg is 2 also, and hypotenuse is 2 rad 2. Cool?
Yeah.
And then if it's 4, I already said it. If that's 4, this is 4. The other one is 4, and the hypotenuse, which is opposite to 90-degree one, it's going to be 4 rad. Cool?
Do you ever use tangent, cosine, or sine to find one of the sides?
We do this, but this is not. It's not this lesson. That's a different lesson. So now, sometimes they might give you hypotenuse and ask what are the legs. If they give you hypotenuse, let me erase these things that I already mentioned it. So erasing this. And if you have hypotenuse, like this hypotenuse, if they ask hypotenuse is 10 rad 2, oh, I already mentioned 10 rad, 20 rad 2, 20 rad 2, right? If you want to find the leg, now what you're going to do, you're going to divide by rad 2. So it's going to be dividing by rad 2, 20 rad 2, divide by rad 2. Basically, you can write like that. 20 rad 2 divided by rad 2, which is going to be 20. You can go opposite also. So they might give you hypotenuse and ask find the leg. You're going to divide by rad 2. So now it becomes tricky. Sometimes students get confused. How about if they don't? Hypotenuse is not 20 rad 2. So let's go different color again here. Hypotenuse is just 20. Doesn't matter. To get the leg, what you're going to do, you say 20 divided by rad 2. You're going to divide by rad 2.
Yeah.
But 20 divided by rad 2, you have to, that's irrational, right? You have to rationalize it by multiplying by rad 2, top and bottom. So that's going to be 20 rad 2 over rad 2 times rad 2 is just 2, which is going to be, that's 2. That's going to be 20 rad 2 over 2, which is 10 rad 2. See, that simplifies. So that's about 45, 45, 90 triangle. Now let's do 30, 60, 90, which is this case. Now there's again relation. I'm going to write that like this. X, not X, 30, 60, 90. So 30, 60, 90. X is the one corresponding to 30-degree angle, the smallest leg. Something that you need to know is always angles are sides are corresponding angles. Means if this is the biggest angle, in this case, which is 90, hypotenuse is going to be the biggest segment. If this angle is just 30, the smallest one, opposite to that, the segment is going to be the smallest segment.
Yeah.
And if now we know this is going to be 60 because if you add 90 plus 30, 90 plus 30 is going to be 120. If you subtract from 180, you get that angle is 60 degrees. Right? So now the smallest one, which is 30, we're going to consider the x, right? The formula here is like this. If this is x, this one is rad 3x, or x rad 3. The one which is opposite to 60, which is this segment, which is this one, is going to be x rad 3. And the one which is 90, so this is x rad 3. Yeah. And the one which is the opposite to 90 degree, which is biggest one, is twice as much as x. So if this is smallest one is x, that's going to be 2x. See, we have relations. One of them is x times rad 3, which is opposite to 61, and then 2x opposite to smallest one, 31, right? X. So always we're going to compare. So this is going to be what? 2x. So if they ask x is equal to the smallest one, which is this one, is equal to 5, therefore this is going to be, if this is 5, the opposite to 61 is going to be 5 rad 3. Oh, so this is 5 rad 3. And then this is going to be 2 times 5. Hypotenuse is going to be 10. That's going to be 10. So that's the thing. And then one more example, if shortest leg is 12, if shortest leg is 12,
this can be 12
opposite to 61 is going to be 12 rad 3.
And then the other one's going to be
24. Now, how about if they ask this one, they didn't give you the shortest one, they give you opposite to 60. They ask, this is equal to 6. So they give you this one, 6. Opposite to 60 degrees. And then what you're going to do to find this, before you were multiplied by rad 3, now you're going to divide by rad 3 to get opposite to 30 degree one, shortest one. So it's going to be 6 over rad 3.
So it's kind of like factoring.
Factoring is opposite of distribution, right? Factoring is kind of division, opposite of multiplication. That's how you can relate. Before we were multiplying, now we're dividing.
We kind of like set up a graph, kind of like.
So let's finish this so I can stop the recording then.
Okay.
So if this is 6, that's going to be 6 over rad 3, right? And then we have, this is 6 over rad 3, this is the smallest one. Then the biggest segment, this, is going to be twice as much as that. So 2 times 6, which is going to be 12 over rad 3. But of course, we need to, these are rational, we need to irrationalize it. These are irrational, we need to rationalize it. This is the opposite. How we would rationalize this, multiply by rad 3, which is in the denominator, we have rad 3. So that's going to be 6 rad 3 over rad 9. I'll go step by step. 6 rad 3 for someone who's watching this and doesn't know it. Rad 9 is equal to 3. So simplify it, divide by 2, divide by 3, divide by 3, get 2. So 2 rad 3. So that's 2 rad 3. This is 2 rad 3. And then to fix this, 12 over rad 3, you multiply by rad 3, top and bottom. This is going to be 9, rad 9, which is 3, and this is going to be 12 rad 3. You simplify it, 12 divided by 3 is 4 rad 3. See, twice as much as 2 rad 3. That was 2 rad 3. So 4 rad 3 is this one. So that's how you do. So one more example. Now, if they give you, so again, let me draw this triangle here and finish this. If they give you this 30, 60, 90, that's 30. And then if they give you hypotenuse, and we know that's 90 degrees, and let's say this is 24. So that's 24. You know this is 30. This is 30. So opposite of that is the shortest one. We're going to compare it always with this one. So that's x. If that's x, let's put it with the angles. So we have 30, 60, 90. If this is now 24, and if you want me, I'm going to repeat the formula. If this is x, that's x rad 3 times 2x. But you need to memorize these. So if you know this is 24, then you can calculate this one, shortest one, which is half of that. If that's twice as much as this, then then this is half of that. So divide by 2, you get 12. And then now you know if this is 12, you can find the other one by multiplying by rad 3. So it's going to be 12 rad 3. All right, that's how you can play with this and find the unknowns. Stop this.